are organisms that do not require oxygen for life and reproduction. Obligate or strict aerobes cannot survive in the presence of oxygen. They may be killed almost immediately. Which is why if someone sends you a culture swab for anaerobic culture, and it's just a normal swab, if it's an obligate anaerobe, it's probably dead. We would still set it up as an anaerobic culture, but we would put that comment on there that it was not received on the proper swab or whatever, so we could have missed something. And it was your fault, not ours. Kind of the reason we do that. The aerotolerant ones, they're capable of surviving in oxygen, but they will not carry out metabolic processes. They will not multiply and divide. They'll just hang out. And the time for this is still usually limited. They can live in oxygen, 4 to 6 hours or so. So you got time to grow these, and that's why on that plain swab, we would still set it up. Because we'll still catch these. The facultative anaerobes, we've covered a lot of these already. They're pretty common. They don't require oxygen at all. If it's available, they will use it because it's more efficient, but they don't have to have it. So where are most of these found? Soil, fresh saltwater sediments, as well as exogenous anaerobes, which exist outside of the body and cause exogenous infections, think tissue infections, things of that nature. We also have them in us. That's what's living in our gut. Endogenous or indigenous anaerobes exist inside the body and cause infections. These cause more infections than the outside ones. Yeah. Yes, sir.
Oh, yes. I thought I was praying. I was like, Jesus Christ.
Why does this sketch have to sleep?
Is that the instructor from next door? No.
No one else is nervous, just me.
Well, we weren't loud today. I mean, maybe yesterday, but I don't think so. Because, other people were in here today.
They're going to be taking a test next door, so we need to kind of
Okay.
Keep it down, yes, sir.
These internal anaerobes that we have tend to not be problematic, but think about your GI bleeds, maybe GI surgeries. When that gets from where it's supposed to be to where it's not supposed to be, we end up with problems. And that's like a lot of these organisms that we've talked about. It becomes more of an opportunist. It's supposed to be inside the gut, not outside the gut. Normal flora of the skin. Believe it or not, we have anaerobes as normal flora of the skin. Usually right below the surface. If they were on the surface, it would not be an anaerobic environment. A biggie, Propionibacterium acnes. You want to guess by the name what it causes?
Acne.
Causes acne. This is one of the organisms they've recently changed the name of. This is now Cutibacterium.
So cute.
That is not how it's pronounced. That's how I pronounce it. And we got into this argument in Baltimore. I said, I don't like Cutibacterium, I like Cutibacterium. All of your older texts are going to call it Propioni, and they'll call it that for 20 years, so be aware of both. The new name is Cutibacterium. But it does cause acne. It's a common skin colonizer. Often a contaminant of blood cultures. It's on the skin. And if it's right below the surface, the alcohol doesn't really get to that. So it can jump in the blood cultures. We have a orthopedic surgeon. Every time he does a shoulder or knee surgery, will send down an anaerobic culture for this organism in particular. And he wants the plates held for 14 days because it's a slow grower. Because he wants to make sure that when he went in and did his incisions and all that, he didn't push this down inside that joint.
Okay.
Actually, pretty smart of him that he's aware of this. But all of his orthopedic surgeries, your doctor, he wants his plates held for 14 days, and this is what he's looking for, just in case. Because if he pushed this into the joint, he wants to know it.
So I have knee surgery, he'll do this on me.
Yes. He'll do an anaerobic culture, and he'll have a note, hold 14 days, and he'll be looking for proprioni. And he'll usually say on the note, hold for 14 days for proprioni. And then 10, 12 years we've been doing this, we have found it once. And he went and treated it, took care of it before it became a problem, no big deal.
Right.
There's one thing about your anaerobes, while they can tend to be very, very serious, these tend to be much, much slower growing than our aerobes. So time is on our side when it comes to these. They're particularly nasty, but they're not as fast. Respiratory tract. Believe it or not, anaerobes like the respiratory tract. Anaerobes like mucous membranes in general because they have that layer of mucus to protect them from the air. So they're under the mucus layer in our lungs, trachea, nose, mouth, all of that. Notice it says that 90% of bacteria in saliva, gingival, and tooth scrapings are anaerobes. Gingivitis, plaque, those are anaerobes. The plaque comes from, it's actually them building a protective layer because they don't like air. That's why they get that nasty stuff on your teeth. This is also what should be suspected in cases of aspiration pneumonia. Kills mom Cass is a shame. Throw up, drown in your own vomit, that sort of thing, because it comes and then goes down.
Yeah.
So you're taking those anaerobes with it.
Mm.
I think, wasn't that Elvis, Steve? I think the aspiration pneumonia. GI tract, obviously. Anaerobes outnumber aerobes 1,000 to 1. That's what our gut is made up of, is anaerobes. Bacteroides fragilis group. Bifidobacterium, which I don't care if you know anything about that. Clostridium, all those are in there. Genitourinary tract. They do colonize the distal urethra. 50% of bacteria in cervical and vaginal secretions are anaerobes. Fusobacterium being a big one, Lactobacillus being another. Factors that predispose patients to anaerobic infections. Human or animal bite wounds. We've already discussed this, lives in the mouth.
Mm-hmm.
You can also think any type of puncture wound. If I stab you with a knife, I could be pushing anaerobes in there. You're predisposed to anaerobic infection. Aspiration of oral contents into the lungs after vomiting. Tooth extraction, oral surgery.
Mm-hmm.
Stephanie.
I'm hanging in there.
Or traumatic puncture of oral cavity. It's already there. So a traumatic puncture of oral cavity. God, how bad would that have to be?
I don't know, man. It sounds
Somebody
terrible.
stabs you in your mouth. That'll teach you to shut up.
Right?
GI surgery or traumatic puncture of bowel. Do a lot of bowel surgeries, bowel resections, things of that nature. Anytime you start cutting around down in there, that's full of anaerobes. You start letting those out and you start having problems. Genitourinary tract surgery for the same reason. And the last big one, introduction of soil into a wound.
Stools filled. Okay.
Happens a lot.
Yeah.
Think more motorcycle wrecks.
Mm-hmm.
You go down and get that nice road rash over 100 yards of asphalt, you end up with a real nasty, dirty wound, and you start picking up this stuff.
This is off topic, but on the news, is Arkansas like the number 3 state for deaths, like delivery?
For what?
C-sections?
Oh.
Stuff like that?
We have, in Arkansas, we have a much higher percentage of poor than a lot of other states other than like Mississippi and Louisiana.
Prenatal.
As a result, these people don't tend to get prenatal care, prenatal screenings, and so mortality starts going up. And a lot of that comes back to poverty.
Sad.
And we tend to, we're a rural state, so even if they're not necessarily like dirt poor starving to death, if they don't have a reliable vehicle, can't get to the doctor. You have to be able to travel in Arkansas.
Not according to the DHS.
Indications of anaerobe involvement. Number 1, infection in close proximity to mucosal surface. We've already said they like to live in the mucosal surfaces under that layer of protective mucus. Number 2 is the biggie.
Foul odor.
You think Protea stinks? You have no clue.
Really?
We were commenting one day in the lab about how foul anaerobic cultures were. We had a phlebotomist, Crystal, who said it can't be that bad. It's like, okay. Well, this is in an anaerobic environment, they're sealed, so all the stink is
I see.
contained.
Mm-hmm.
So we opened it and did that, and she stuck her face to it, and I had to catch her, she went to her knees.
Oh,
It was that bad. You think, like I said, you think Proteus is bad.
I'm not sticking my nose in.
These are especially foul.
Do we have any other plan?
No, we do not. Presence of large quantities of gas. This will not do as like some of the TSI or whatever where it has a few bubbles. This will blow the lid off.
Okay.
Cool.
If you get an anaerobe in a blood culture, you know in a blood culture you have to pull some blood out with a syringe.
Mm-hmm.
I've seen it where on the anaerobic bottle, you stick the syringe in, the plunger goes,
What?
Because it's pressure.
yeah. They build up a lot of gas. Presence of a black color or a brick red color. A lot of these anaerobes tend to be highly pigmented. Black seems to be a popular color. A lot of them will fluoresce. And the last one, presence of sulfur granules. We've discussed another organism that will do this. Remember?
Yeah, you're talking about the well water and that one?
No.
No.
Nocardia.
Dang.
There's an organism in the anaerobic group that is very closely related to nocardia. And nocardia produces sulfur granules as well. But the biggest indicator, that smell, it is unmistakable. There's a small list of anaerobes, but that be
I
not.
think so.
Oh, small.
So the first group we're gonna talk about, Clostridium. They've changed the name of this one too. It's now Clostridioides. All spore-forming anaerobic bacilli are in the group Clostridium, or Clostridioides if you want to use the new name. Clostridia may be grouped according to placement of spores. They may be terminal, subterminal, or central. Spores can survive heat treatment of foods. This is why anaerobes can typically cause a lot of food poisoning, because even if we cook it, even if we can it and all that, that kills the bacteria, does not kill the spores.
Botulism.
Remember, cooking, canning, any of that sort of stuff kills bacteria, does not kill toxins, does not kill spores. Clostridium perfringens food poisoning usually follows ingestion of enterotoxin producing strains in contaminated foods. If the food has been heat treated or cooked, that will kill the bacteria, will not kill the spores. So even if you eat it, those spores will germinate and it'll spread, and then now you've got the infection. Improper storage of food then allows spores to germinate, etc. There are two types. Type A poisoning. I bet most people in this room have had it. Mild, self-limiting, 8 to 12 hour incubation, diarrhea, and cramps for 24 hours.
Yeah.
That's another one of those one-day stomach bugs that goes around, fairly common. No big deal. Type C is more serious, but much more rare. The incubation is much shorter, 5 to 6 hours. Acute onset of severe abdominal pain, diarrhea often being bloody, vomiting, and necrosis of the bowel. It's so bad your bowels will die. Fatality rate 15 to 25% without treatment, probably 5 to 10% with treatment. And treatment involving removing a large section of bowel. Botulism. Sure you've all heard of botulism. Foodborne botulism caused by ingestion of the preformed toxins produced by Clostridium botulinum. Extremely potent neurotoxin. Even a small amount can produce paralysis and death. Most common sources: home canned vegetables, home cured meats, or any other preserved foods. Symptoms vary anywhere from 2 hours to several days. This is what they're worried about when they tell you, do not let an infant have honey. Honey is a common source of botulism. It even says that at the bottom. Most common food source is contaminated honey. You can also get wound botulism, which is when the spores themselves contaminate a wound. These are potential bioterrorism agents, the bacteria and the spores and the toxin. They can all be used as agents of bioterror. Tetanus. It's another one. Tetanus is a Clostridium tetani. The symptoms come from another neurotoxin, tetanospasmin. Toxin acts on neurons, preventing the release of neurotransmitters. Results in continuous muscular spasms. Leads to trismus, which is lockjaw, which is why tetanus is often called lockjaw. Just a nice bit of trivia, the way they used to treat it is they would knock your corner teeth out. And they had screws, large wooden screws they could inject there and screw them in to force the jaw open like jacks.
Oh my God.
So if you went back in the 1800s and you saw somebody who was missing these two teeth, you knew that they had tetanus and survived it if they're still walking around. Most people don't. The muscular spasms and the locking of the muscles can cause difficulty breathing, rigidity of jaw, neck, lumbar region, can cause death if it's severe enough to stop the diaphragm. It paralyzes that muscle. Tetanus occurs when the spores vegetate and produce toxin at the site of a puncture wound. The old school story is you get tetanus from stepping on a rusty nail. That's the most common. The tetanus and the spores go into that puncture site from the rusty nail. Anaerobes tend to really like rust because that layer of flaky rust gives them an anaerobic environment. They like that. So the whole thing with rusty nails and tetanus, that is actually legitimate. It's no longer common in the U.S. because of the DTaP vaccine. Therapy requires antitoxin and constant nursing and supportive care. Basically what's gonna happen, if you get tetanus and it makes it that far, they're gonna start administering antitoxin. In the meantime, your body's still shutting down. You're gonna have to be ventilated to keep your lungs functioning long enough for this to run its course. It is survivable now. Before the vent was invented, it was almost not survivable. It was a rare occurrence. If you saw somebody missing these two teeth
Walking around.
from tetanus, because I mean, that was a death sentence. Gas gangrene. This is another one caused by Clostridium perfringens. Myonecrosis, also gas gangrene. Usually occurs when organisms contaminate wounds through trauma or surgery. Most commonly, back in the day, gunshot wounds in war. Other Clostridia can be responsible, but perfringens is most common. The organisms will grow and release the potent exotoxin, causing necrosis of the tissue with pain, swelling, discoloration of tissue, fluid-filled blisters. Onset and spread is rapid, yes.
Is this gangrene, similar to the one that comes after you've been frozen and you stick your hand in?
Very, very similar, very similar.
Is that other one though a different one?
It is a different one, yeah. It's called gas gangrene because you notice I said a lot of these produce large quantities of gas. There will be huge gas bubbles inside the skin and tissue that you have to like stab and puncture, and they'll like spew, and it's great. All that fluid and gas comes out. It's like popping a balloon.
Yeah.
Treatment involves extensive surgical debridement. They have to scrub all of that dead tissue off. Most often will involve amputation. Some of the newer methods, possible use of hyperbaric oxygen chambers. This is becoming more and more popular for anaerobic infections. Because hyperbaric oxygen chambers, it's high pressure oxygen chambers. You go in there and lay in it for a couple hours and it forces oxygen into every tissue of your body. This stuff doesn't like oxygen. It will slow down all of it and outright kill a lot of them. So this is actually a great therapy. You can take something that should cause death in a matter of hours. you can ride somebody out for months. If you're giving them daily or even multiple times a day therapy sessions in hyperbaric oxygen chambers. A lot of your bigger hospitals are starting to get this. I know UAMS has a hyperbaric oxygen chamber. Baptist in Little Rock has one. Children's has one. Your bigger Little Rock, hospitals, they're starting to go to this. There is one problem with being in an environment of pure oxygen. You might know what that is.
It's not, yeah,
Blindness, it makes you blind.
yeah, it's not good for you.
But would you rather go blind or go deaf?
So the same agreement they did, there's what they did on my toes.
Probably, yeah.
It saved my second toe though.
This is one, if you're working in the hospital, you have to know.
C. diff.
Clostridium difficile, C. diff,
Stinks to
C.
high
diff,
heaven.
however you wanna call it, is the most common cause of antibiotic-associated diarrhea and colitis. What does this mean? This naturally lives in the gut of most people, and it's never a problem. When it becomes a problem is if you have an infection and they put you on a lot of antibiotics. That kills a lot of your normal flora, allowing this to take over. It is highly contagious, highly infectious. That is why if someone has C. diff, they're under contact isolation. It is gown, gloves, mask, everything to go in that room. When you come out, you have to strip all that off. Because if you don't, you go from here to here to here to here to here.
Everything's
40 people have C. diff. An experienced nurse will know if a patient has C. diff without doing a single test. Because the diarrhea produced from C. diff has a very distinctive odor, and it's bad. You walk into rooms like, that's C. diff, let me get a gown. I mean, it's that bad.
This is why they give you probiotics to try to keep that from happening. Cause it's supposed to help encourage the,
Probiotics are almost useless.
really?
I'll tell you why, because almost all of it is in pill form, and when you swallow it, it hits the gut, the acid in the stomach kills it.
Oh.
What they're doing instead,
Fecal transplant?
fecal transplant. They're taking stool from normal healthy people, putting it in a cup, stirring it up with water, pulling it up in a syringe, and squirting it up somebody's butt.
Oh.
To transplant that normal flora back.
That's what they do with
Yeah,
cows.
I ain't doing that for you.
You're gonna have to let me die.
You and me both. Not happening.
Perfringens is the most commonly isolated anaerobe in bacteremia. So when the anaerobic blood culture bottle goes off, this is already our suspect. Notice another one, and the only thing this is notorious for, Clostridium septicum. When you see that in the blood, that is a marker for malignancy in the colon. Because it should be in the colon, it's supposed to be in the colon. So if it's getting out of the colon into the blood, there is usually a large tumor with a active blood supply in the colon that allowed it to jump. So that is the only reason that one is really significant. So, so gram-positive, non-spore-forming anaerobic bacillus, Actinomyces. When I say Actinomyces, you put it with nocardia. They go together like this. They look alike. They act alike. One of them's aerobic, one of them's anaerobic. I don't care about Bifidobacterium, Agaricella, or Mobiluncus. Lactobacillus you do need to know. We've already talked about this one quite a bit. Propionibacter we've already mentioned. They are considered opportunists. The microscopic morphology ranges from short rods to long branching filaments. The long branching filaments, primarily Actinomyces. Remember how nocardia I said could look hair-like? The long branching filaments. Actinomyces looks just like it. Actinomyces causes a chronic granulomatosis infectious disease. Actinomyces loves the sinus tracts and the tonsils. It will produce fistulas that will erupt and drain pus containing sulfur granules, like nocardia. If you examine a wet mount or a gram stain of that pus, you'll see non-sporing, thin, gram-positive bacilli that may show branching. Since this can be normal flora of the oral cavity, most cases of this are seen in the maxillary region with draining sinuses in the neck and thorax. May also be seen in female genital tract. The most common species of which is Israelii. How they diagnose it, they actually don't culture actinomyces very often. I mean, you find it, but not on purpose. When they remove someone's tonsils, they will actually cut and make a slide. And if they see this, if they see the branching bacilli and the sulfur granules, they're done. That's actinomyces. That's why you have to get your tonsils removed.
Okay.
My daughter actually had it. And it's very common when tonsils get swollen and stay swollen, and they end up having to go in and cut your tonsils out. This is a common culprit. They said my daughter had it in the left tonsil, but not the right, but whatever. But that's how they didn't culture it. They cut it, stained it, looked at it, and they saw it. Period, you're done. There's your problem. Luckily, removal of such corrects the problem. Of course, when it gets in the sinuses, we can't remove those, we gotta treat that, but most common, it likes to jump on the tonsils. Yes?
So, actinomyces is differentiated from nocardia in its, atmospheric requirements.
Yes.
Nocardia being aerobic. Thank you.
Yes. But other than that, as far as look and all that, they look just like they're very closely related. Bacterial vaginosis, BV. We talked about this a little bit. Foul smell, discharge, all of that. Thought to be caused by a synergistic effect of multiple organisms, one of which we talked about was Gardnerella vaginalis. Most likely caused due to a decrease of lactobacillus. It is a gram-positive, highly pleomorphic bacillus. May appear on gram stain as coccoid or spiral shape. Excuse me. It's aerotolerant, which is why it survives in the vagina just fine. Widely distributed in nature, normal flora in the mouth, GI tract, female genital tract. Bacterial vaginalis may result if balance between lactobacillus and the other normal flora is upset. The species of which is the Acidophilus complex. There's multiple species in there, closely related. Lactobacillus produces lactic acid, which lowers the pH of the female vagina, which keeps a lot of this other nasties from being able to grow. So anything you do that alters your pH or kills your lactobacillus is likely going to cause some sort of bacterial problems. That is why in the last 25, 30 years, I guess, they've said one of the worst things you can do is douche. That used to be a popular thing. Now they say don't freaking do that. You're washing your normal flora out. You're messing up your lactobacillus. All you're doing is causing problems. Self-cleaning oven, leave it alone. Endocarditis is the most common clinical disease caused by this. It has a 23-27% mortality rate. So when this gets somewhere that it's not supposed to be, it likes to jump to the heart, or the lining of the heart at least. Typically it stays where it belongs. I've never seen this jump to the heart, even though I do understand that it's possible. It is difficult biochemically to differentiate from Streptococcus viridans. But as soon as you do a gram stain, this is not a gram-positive cocci. I mean, Strep viridans, it's a strep. It's a very small gram-positive cocci. So the gram-negative, non-sporing bacillus, most commonly encountered is the Bacteroides fragilis group. I don't care about Porphyromonas or Prevotella. We'll talk a little bit about Fusobacterium. Frequently caused found with mixed infections. You will almost never find a positive anaerobic culture that just has Bacteroides. It will be 5 different species of Bacteroides with a Fusobacterium, maybe a Lactobacillus. It'll be a mess. This stuff, it's a gang member. They don't like to travel alone.
Mhm.
Causes abscesses and sepsis. If you get a anaerobic abscess, number 1, that is some serious stink when they drain that. Number 2, when you culture it, the plate's gonna be a mess. This is another one that will jump to the blood. You'll find it in blood cultures every now and then. Unfortunately, when you find it in blood cultures, again, it doesn't like to be alone. You'll find multiple ones. Fusobacterium, frequently associated with brain abscesses. How bad is that gonna be? It's naturally found in this area, oral surgeries, so it jumps from here to bloodstream. I mean, we're talking it's gotta go that far. Jumps to your brain, causes a big nasty rot,
People survive those.
very rarely.
Okay.
Another reason why I get my people.
The anaerobic cocci, I don't even care about the gram negative. The gram positive is kind of important. You will see Peptostreptococcus from time to time. It'll look very much like a strep. It's a small gram positive cocci, but it will not grow aerobically. So when you see something that looks like a strep, but it's only growing on the anaerobic plate, Peptostreptococcus. Associated with a wide variety of infections, brain and lung abscesses, aspirational pneumonia, gingivitis, and other mouth diseases. And it's another one associated with multiple organism infections. Specimen quality. Here's where I talk about getting the wrong swab. It is of the utmost importance, especially with anaerobes, that we get the correct specimen. If it's a swab, which is not preferred, it's gotta be that right swab, the one with that gel in it to protect that anaerobic environment. We would much rather have, if they're gonna drain an abscess, stick a needle in it and draw some out. Aspirate it, don't swab it. Send us a big syringe full of pus. Should be transferred from syringe to oxygen-free transport tube. You're not gonna see these very often. The ideal situation here, get this to micro. If you want an anaerobic environment, or anaerobic culture, you get it to me as quickly as possible. Let me get it set up. You know, you shouldn't be wasting so much time. You need oxygen-free transport tube. That means you're gonna be waiting an hour to bring it to me. Draw it out, send it down. Simple as that. Swabs used only when aspirate or biopsy material is not available. Very rarely is that the case. Send me some pus or a piece of meat or something. The oxygen-free transport, that's the one with the gel in it. Swab it, what's these blue ones?
Yeah.
And you stick the swab down in that gel, which keeps the air off of it.
But it's still not ideal. It's still not ideal.
Still not ideal.
So
Tissue may be placed in O2-free transport. Larger specimens may be transported in anaerobic bags. They don't have those in surgery. Ideally though, when they send you a piece of meat from a biopsy or something they cut off, even if there's anaerobes on the outside of it that are going to die, there's still anaerobes on the inside of it that are just fine. So the way we set up tissue cultures is we grind them into a paste. Don't gag a little bit in your mouth there. We put it in a tube with a little bit of thiol, it's like a mortar and pestle. Grind that up. Then we free that stuff from the inside that's still good, still viable, and set it up immediately. Blood, collect aseptically into anaerobic and aerobic bottles. Blood cultures are always done in pairs. That's why there's always 2 bottles. There's an aerobic bottle and an anaerobic bottle. The anaerobic bottle, If I remember right, and this may vary by manufacturer, I think it has nitrogen in it. Only properly collected and transported specimens should be processed, with a caveat. If they send me that swab, I'm still going to set it up. But I am gonna put a comment on that culture that it was not sent on an anaerobic swab. If they collect this in a regular, non-anaerobic swab, and it sits in OR overnight, I'm not setting it up at all. That's garbage, don't even bring it. But they're going to bring it to you the next morning, and then they're gonna get mad when you don't accept it. Too bad, I'm not wasting my time. Following procedure should be performed. Macroscopic exam of the specimen. Obviously, what do you have? You have a fluid, do you have a swab, do you have a tissue? I mean, describe that. And ours actually has a spot when we're resulting this or setting it up, what is it? Because all they say is, we have a culture report on John Doe, or a culture specimen on John Doe. That's what the order says.
Right.
We have to go in and say what we got. Gram stain smear prep, only if ordered. They don't always order a gram stain with it, it's not automatic. Inoculation of appropriate tube and plate media, including specialized anaerobic media and anaerobic incubation. This will go in the regular incubator, but it will go in the incubator inside of an anaerobic bag, jar, box, whatever your facility uses. And all of which are available for anaerobic environments. Candle jar is not good enough. That is decreased oxygen. There's still enough oxygen in there that the anaerobes don't care for much. The microscopic, we already said, direct microscopic, if ordered. Inoculation of primary plated and tube media. The ideal anaerobic media is a media that was made, produced, and shipped and never been exposed to oxygen. Good luck. What a lot of places will do though, is when they take, as soon as their media comes in, they'll take a bunch of those blood plates and they'll shove them in an anaerobic bag and put them in an anaerobic environment and then put them back in the refrigerator. Because what that will do is over a period of 24 hours or so, that will actually pull a lot of the oxygen out of those plates. So now, when you have an anaerobic culture, you go grab one of those blood plates because it's reduced oxygen from the regular. And then you reseal the bag in an anaerobic environment, put the rest of them back in the fridge. Media stored under anaerobic conditions or purchase price media. Plated at room temp. I have no idea what price media is, never heard of it. But at the very least, you want to store some of your media in an anaerobic environment, because it does better. CDC agar, which is an anaerobic blood plate, is the best all-around media. That's the one that's produced, shipped, and all that in an anaerobic environment. I've never actually seen this stuff. It's probably expensive, that's why I've never seen it. Protocol is only properly collected and transported specimens should be processed. Again, with that caveat I mentioned. If it's sitting ORO all night, no. If they get it to me pretty quick, I'll set it up, I'll just comment on it. If available, process specimen in an anaerobic chamber. These are cool, and Baptist has one. First time I've seen one. They have a, looks like a sandblast cabinet with the arms, with the built-in gloves you stick your arms in. This whole container is anaerobic. So you open the door over here, you put your specimens in, close the door, wait for the light to come on, and then you reach through and you pull them and set everything up here, and then put it in a box that you then seal, put it back through the door, open it, pull it out. It has never been exposed to oxygen.
That's cool.
All right, it's a cool setup. The best part of that is, because they also read them in there. The next day when they're reading their plates, they put the box back in and then they look at them. You're protected from the aroma.
Nice.
Huge plus. may include thio or chopped meat as a backup broth. Wait a minute, thio is not an anaerobic tube. It's just a broth. But the bottom, if you don't mix these tubes up, and you shouldn't, if it only grows at the very bottom of that tube, if you see cloudiness only at the bottom, that's anaerobic. If it's growing up at the top, it's exposed to oxygen. So a lot of times when you carefully take that out and look at it, you know then what you're dealing with. And even if they did not order an anaerobic culture, if you're just setting stuff up aerobically, and you pull that out and you see growth at the bottom, now we're adding an anaerobic culture. Because something is there anaerobic. Chopped meat's the same way. And it is exactly what it sounds like. It's chopped up meat in juice in a tube. Right here, I love that stuff. If all they order is an anaerobic culture, you are still going to do an aerobic culture. You can do an aerobic without an anaerobic, not the reverse. Because what we're expecting to find most of the time is aerobic
Where did you
organisms.
say that?
So even if they don't order an aerobic culture, we're still going to do an aerobic culture. So for the incubation, there are anaerobic chambers that we've already mentioned, the big box with sleeves. There are anaerobic jars, kind of like a candle jar. It's more like the big plastic one I've been using instead of the glass jar. You put your plates in there, you put a reagent in there and seal the lid, and the reagent produces a oxygen-free environment. It actually absorbs oxygen. Because one of the things it contains is platinum, which absorbs oxygen. So those are expensive.
Platinum?
Platinum. Anaerobic bags are most common. Believe it or not, at National Park, we use a food saver system. Not the bag, but the sealer. We put our plates in the anaerobic bag with the reagent and an indicator. We stick it in a food saver and seal it. Then through the bag, you can pop that reagent. It's a glass vial, kind of like their endo droppers. And it will absorb the oxygen, producing an anaerobic environment. There's also an indicator in there that you're looking at, like the next day when you pull it out, it's pink. Okay, it's an anaerobic environment, it worked. Pull it out the next day and it's white, we just killed it. So, hey, we tried. But yeah, we actually use a Walmart food saver to seal our bags, it works great.
That's cool.
Well, you can order the medical one for like $400, you can go to Walmart, get a food saver sealer for $15. So there's multiple ways to achieve an anaerobic environment. The most common is bags. They're cheap, they're easy. Once they're in a bag, you can just throw them in a regular incubator at 37 degrees. When to examine primary plates. It says, can be examined at 24 hours if anaerobic conditions are maintained. I don't know anyone who looks at anaerobic cultures at 24 hours. They take too long to grow. Most people don't even look at them until 48 hours. And you have to hold these longer. 8, 10, 14 days, 20 days. Because most of these are so slow growing. If you looked at it at 24 hours, it ain't no growth, you threw it away. It might have shown up on day 5. So they're held longer.
Is that like per like facility you work at, or is that per physician request? How long the hell? Like you did guys
That's according to your facility's procedures, has
Okay.
nothing to do with the physician.
right on. What do you?
Now, what Becky will do at National Park, the anaerobic bag she uses are clear. The lids of your plate are clear. So she can actually, without opening, hold the bag up and say, no growth yet, and never open that to break that environment and then have to reseal it and redo everything.
Okay.
You can just look straight through the bag. Then if you see something, go ahead and crack it up and see what you got going on. That's another reason I like the bag. Indications for the presence, again, foul odor upon opening that bag. It's in that bag and it's all nice and sealed and contained. It just maintains and brews in that stink. It's lovely. Chemistry at National Park is right beside micro. Becky used to love to torment me. On anaerobic day, she would open her door. Walk over and slam. As soon as she cut the first bag, it's like, ugh, God. I'd go shut the door, it was awful.
Stomach journal.
You said you came to say how last week.
I did.
You wear a mask or like put pressure around?
Microtechs are immune to this. By the time you finish micro rotation, you're gonna be immune to these smells. When you're exposed 8 hours a day, all that.
Y'all see me with big
When you're examining your plates, if there's growth on your anaerobic
I
blood,
got used to it.
but not on your regular
'cause they
blood
used to
plate,
throw all of their meat.
that's an automatic
fatty
indicator we're
away
dealing with an anaerobic.
into a trash
They didn't
can.
like this
That
aerobic plate, they grew on the
was
anaerobic
the,
plate.
back in the truck where they keep everything in the little trucks. which is
Good growth of gray colonies on BDE. That's Bacteroides bioesculin agar. That is notorious for, Bacteroides fragilis. Colonies on either KBLE or anaerobic blood plate that fluoresce brick red under a UV light. You'll see a lot of microlabs, if they have a lot of anaerobic cultures, you'll see a little cheap UV light thrown up on the counter. And they'll shine them over their plates. And they're looking for this. Double zone of hemolysis on anaerobic blood agar indicates Clostridium perfringens. So what is a double zone of hemolysis? Right up close, real close to the colony, will be beta hemolytic, real strong, like Staph aureus, clear. And then weakly around it, you will see a much lighter hemolysis. It's a double zone. Processing is not much different than an aerobic plate. Describe the morphology, tell which plates it grew on, which plates it didn't, gram stain morphology. You can do aerotolerance testing to see if you kill the organism. Most people don't bother with that. And then you want to inoculate a pure subculture. This is where we get that subculture, especially the Bacteroides that likes to grow and bring a family to the party. Being able to pick out that isolated colony and get a good, pure subculture. If you've only got one colony type, then you skip that step. So again, fluorescence, you have to use special potency antimicrobial disc if you're antibiotic testing. Anaerobes are a little bit tougher than their aerobic cousins. You gotta have stronger antibiotics to kill them. So there is a difference between the antibiotic disc for anaerobes versus aerobes. You have to know your dosages. Catalase spot endo motility test may also help you. Lecithinase and lipase reaction on an egg yolk agar. I think I've got pictures of some of that in a moment. The biochemical base uses a lot of the same test as conventional biochemicals. A lot of these will still respond for catalase or indole or oxidase or all that. API makes these little biochemical strips that we've talked about early in the semester, and you can set up the exact same thing and put it in an anaerobic bag and do it the exact same way as you would an aerobic. You can do all of the biochemical tests the same as you do for an aerobic. You just have to do them anaerobically. Put them in an anaerobic bag, anaerobic box, something of that nature. You have to keep your organism in mind when you're setting up these tests. Now they're slower, so there will be protocol in place wherever you go that instead of reading that citrate reaction at 16 hours, maybe you read it at 32 hours or something of that nature because they're slower growing. The very last one that is becoming more and more popular, 16S ribosomal RNA gene sequencing. That is the biggie now. If you go to large city hospitals, this is what they're doing. Little Rock is not a large city, they're not doing this. Primarily done around here in reference to research labs. Ribosomal DNA is extracted from the organism and amplified and then compared. They compare the sequence to known organisms. We had a big discussion at Baltimore about this. One guy was complaining, everybody should be doing this test. And he was from Philadelphia, and we're like, everybody ain't got a $25 million budget, buddy.
Is it more accurate?
Huh?
Is it a little bit more accurate? Or?
It's very accurate. It's like almost 100% accurate.
But 25 million.
But it's fairly new and it's extremely expensive. Smaller hospitals are 50 years from being able to afford this.
Yeah.
Unless the federal government steps in and starts funding some of this, it would not be a bad idea.
It's not a matter.
So, identification of Clostridium. Boxcar shaped gram-positive bacillus with a double zone of beta hemolysis on blood is presumptive for Clostridium perfringens, or Clostridioides perfringens. Still can't get used to that name. Here's another swarmer. A swarming gram-positive anaerobic bacillus with terminal spores is indicative of Clostridium tetani. Clostridium difficile can be cultured for. No one cultures C. diff. It is too fast, too accurate to do antigen testing for this. Take the stool, you put it in the kit, you add a couple reagents, you pour it on here, it tells you positive or negative. It takes 20 minutes. No one cultures for it anymore. UG at CHI, he's got a new molecular machine that does CDT now. You take a swab, get a little poop on it, stick it in this machine, it tells you if C. diff's present. Done. And actually do a couple more. It'll do C. diff, Campy, a couple others in there. Here's that double zone of hemolysis for Clostridium. If you look closely right around the colony, see how bright it is?
Mm-hmm.
And if you look farther out, there's this lighter zone of hemolysis. It's a double. It's got a really, really small zone of strong beta hemolysis surrounded by a weaker zone that looks like it's trying to go
What?
beta. Like maybe if you give it a few more days, it'd be beta. But that is very indicative of Clostridium perfringens. Yes,
What was the alpha one style of hemolysis?
alpha prime.
Alpha prime, yeah.
It's the exact opposite of this. Right around the colony will be no hemolysis. And then out here will be beta. This is that egg yolk armor. I gotta find notes on this because I don't know what about it. The lecithinase reaction occurs within the media. It is inside the media. It will turn this white color. The lipase reaction is on the surface of the media. It will spread out this metallic looking sheen. That is a positive lipase reaction. Identification of the non-spore forming actinomyces, straight to slightly curved rods. Some will be short, some will be in long filaments. Think nocardia. Young colonies frequently look spider-like or woolly looking. Others may resemble raspberry or what they call a molar tooth colony. Think of your molars, other than Stephanie, she doesn't have any anymore. The little white bumpy ridges on it, that's kind of what it looks like. It looks like when you look at the colony, you're looking at the top of a molar. It's very distinctive. What was the distinctive colony appearance of nocardia? Anybody remember? It said breadcrumb-like.
Oh, yeah.
White, bumpy looking colonies. A little bit different, but very similar. You can almost think of actinomyces and nocardia interchangeably in most things, other than in the incubation environment. Skip the middle two, don't care. Propionibacter, gram-positive anaerobic pleomorphic, can range from coccoid to long branched filaments. I've never seen this in a branching filament. I've heard of it. It's usually a little bitty short rod, more of a coccobacillus. Can appear as diphtheroid. What's our other dipteroid?
Oh,
Cornybacter, Corynebacteria. This can look a lot like that, but again, it's an anaerobe. It is catalase NO positive, frequently isolated from blood cultures because of what? It lives under the surface of the skin, where that alcohol white doesn't get. It's like the needle picks that up on the way through. It is often dismissed as a contaminant because it is normal flora. Although in extreme circumstances, it can cause SBE and bacteremia. SBE is subacute endocarditis. Rare. Probiotic is usually a contaminant. But again, we do have an orthopedic surgeon who's looking at it. He's looking at it for a contaminant that may be put there. He wants to prevent that. Like I said, he's done it once in 10 years that I know of. I've only seen one of his come up positive. He does a good job. You're in good hands. Bacteroides. Of all the stink of anaerobes, nothing compares to Bacteroides. You will throw up in your mouth a little bit. It is the most clinically significant. It is extremely common. Can be divided into two groups, bile tolerant and bile sensitive. The bile tolerant is the Fragilis group, and that's the one we care about. We don't care about the others. The Fragilis group includes 20 species and is especially pathogenic. It is the most common species of anaerobic bacteria isolated from infectious process of soft tissue, responsible for greater than 60% of infections caused by the group. Fragilis appears on BBE, which is Bacteroides bile-esculin agar, as gray colonies that turn the light yellow media brown to black. The media is naturally a light creamy yellow, and it's used just looking for this, because if you look at it the next day and it's a real dark chocolate brown, like a burnt chocolate color, almost black, it's Bacteroides. Prevotella porphyromonas, you need to know about them. We're not going to cover that too much. You have heard the name. And they are anaerobes. Fusobacterium, long, thin, tapered rods, and be a little bit pleomorphic. Long, thin, tapered, pointed rods. It's called Fusobacterium because it is a fusiform bacilli. Remember that from the very first couple of lectures, the shapes of the bacilli? Long, thin, pointed. That's how it got its name. Almost all of them, except for one, are endocausative. All will fluoresce a characteristic chartreuse color under UV light. That's the reason you see these UV lights in a lot of micro labs. If they do a lot of anaerobic cultures, somewhere in a drawer or thrown up on a shelf, you'll see a UV light somewhere.
it's like a lime and green.
Susceptibility testing of anaerobes remains extremely controversial. They're fairly predictable in their sensitivities. They're also slow growing, so if you do it conventionally, it takes a long time. It takes specialty antibiotic disc. It's generally difficult to perform. As far as resistance, Bacteroides fragilis, it's historically resistant to a wide variety of things. Resistance of other anaerobes is increasing. Luckily, it's increasing slowly. So Bacteroides, maybe you have to send out for susceptibility testing. The rest of them don't bother because they already pretty much know how to treat it. The problems in susceptibility testing, there is no gold standard. No one can agree on which method is best. And so depending on where you send it will depend on the method used and perhaps the results you get back. Most common is probably broth microdilution. Those are generally done in these. They'll do a variety of dilutions against an antibiotic, and they'll look for clear versus cloudy. If it's clear, it worked. If it's cloudy, the bacteroides grew. The problem is, you're gonna use 10 to 15 wells for each antibiotic. Not only for each antibiotic, but for each dosage of an antibiotic.
Wow.
So this whole plate may only do 2 or 3 dosages of the same antibiotic. So to do a complete battery of this, you may have 5 of these for one organism. That's why people don't like to test these. They also, test by the E-test. We covered the E-test yet? Ellen?
I don't think so.
Different test. I'll draw it on the board and I'll tell you.
I think.
I couldn't remember if we had mentioned it or not. I know it's in an upcoming chapter. 4 approaches to the management of anaerobic infections. Unfortunately, number 1, surgical. Cut it off, cut it out, drain it, whatever you gotta do. Hyperbaric oxygen, becoming much, much more popular, luckily, because it's very effective. Forces oxygen into the necrotic, oxygen-starved tissues. They'll do this for multiple days, and surgery may still be required, but they'll be cutting out a lot less than they would have before, because they can save a lot of it now. Antimicrobial therapy, it's often ineffective, because it takes high doses and it takes a long time. If you have a life-threatening anaerobic infection, they figure out what antibiotic is gonna work, they're going to give you a near lethal dose of this antibiotic. They're gonna push it to the absolute limits. This is the reason we do so many peaks and trough antibiotic levels on patients, because they are pushing them to extreme levels trying to save their life. If available, antitoxins will be used to neutralize some of these toxins that these produce, especially tetani and botulinum. Erase Rick's bull. Smear. The E-test is an antibiotic strip. It's a long, narrow strip. Let's say this one is vancomycin. It is differentially soaked in antibiotic. So starting up here is maybe 1 milligram of antibiotic, and maybe 5 milligrams, then 10, and 15 milligrams. So as you come down, it's stronger. So what they're looking at, when you set this on a plate and inoculate it with this organism, it will form a growth pattern kind of like this. Actually, I think I drew that backwards. It should be the other way. That's confusing. So if you get down there at these high doses, all of this is growth.
Okay.
All this is growth. You have this clearing. You can see these high dosages work. Where this terminates is the weakest effective dose. So this one would be somewhere around, what, 6 milligrams?
Okay, that makes sense.
6 milligrams of vancomycin is the lowest dose that was effective. Because all of this up here, it grew right up to the strip.
Kind of like a titer.
Very much like that. These E-test strips are expensive, but instead of using 10 different discs, you can get the same information out of 1 strip. Because to do it the other way, you have to have a 1 milligram disc, a 5 milligram disc, a 10, a 15. You've got 4 discs just to do what this can do. So these are very, very good. And you can actually do on an agar plate, you can do 4 different antibiotic strips and do titers of 4 different antibiotics at one time on a normal sized blood autoclave. So they're very, very good. They're a little hard to read because you end up with situations where this is your strip and it grows like this. It's like, okay, how are we gonna interpret this one? Personally, I would go with this line. But there's some confusion and all that. And then what if it grows like this, but then you have another colony that does that? You know, it's not a perfect science, but it does work pretty well. It gives you a lot of information off of one strip, and that's why you're starting to see a lot of e-tests. And believe it or not, this is very, very old school antibiotic testing that is coming back. One of our doctors at National Park, she finally said, you know what? I don't like the results your machine's giving us. I don't like the results I'm getting from reference lab. I want all my vancomycin testing done by e-test. As a result, we have a bottle full of e-test strips in the refrigerator at National Park. She likes the e-test, that's what we did. Took a lot of argument because she had to go to administration and justify the increased cost, because these are expensive. As you think about it, it's kind of hard to soak a piece of paper incrementally in antibiotic. It's not the easiest procedure in the world to do. So she had to justify it. They said, okay, they said the reasoning justifies the cost, go for it. So we ordered them up, we started doing them for all of her vancomycin. But you can get these e-tests in every antibiotic you can think of, if you're willing to pay the cost. But it's really good. I mean, like I said, instead of having 4 or 5 discs, and they've actually got more numbers on them than that. They're actually, when you look at them, they're more like this. You get a lot of dosages out of it. But they're pretty good. Better than disc. Yeah.
Before we do our review, we have a 10-minute break.
We'll have a 15-minute break, we meet in the lab briefly and then do a review.
Okay.
Make 15.